Hello everyone, welcome back. Now the topic is creational patterns. Under it, we're going to discuss about factory method design pattern. So what is factory method design pattern? Basically, it is a creational design pattern that defines an interface or abstract class for creating an object but delegates the actual instantiation of the concrete classes to its subclasses. So the main benefits of this factory method is loose coupling. The caller only depends on an abstract interface or base class, not the specific concrete products. And flexibility and extensibility. New product types can be added without modifying the existing client-side code, adhering to the open-close principle, which is basically one of the principle of solid principles. And encapsulation. The logic for deciding which specific class to create is centralized within the factory methods. And the final one, testability. It is easier to use mock factory implementations in unit tests. Don't understand, right? It makes more sense when I go through bad and good examples of using this factory method. So then it makes more sense. So let's get into the code. Let's understand this factory method with a simple real world example. Imagine an e-commerce application. When the order status changes, we may want to notify the customer using SMS, WhatsApp, or email communication. Now, I'll show you the bad way first. So let's go to this creational factory method bad. Then we'll fix it using the factory method design pattern. So if you look into this code, basically here we are checking the notification types using if-else conditions. So if the notification type is SMS, then we'll create SMS notification object and calls the method send with the message your order is shipped. So let's quickly look into what is this SMS, WhatsApp, and email notification classes are. So basically we created an email notification class with the method send, which accepts a message and just prints email sent with the message. Same like SMS, we created SMS notification class with the same method name send and prints SMS sent. Same with the WhatsApp as well. WhatsApp notification and send method prints WhatsApp message sent. So let's come back to the main method. So if the notification type is WhatsApp, then we create WhatsApp notification and calls the send method with the message your order is shipped. Same with the email as well. We check for the email, we create the email notification object and we call the method with the message your order is shipped. This works, but here is the real problem. If tomorrow the business says add push notification or add any other new kind of notification, you must come back to the same file and add one more else if block here. So if else keeps growing. Also, if you notice, this class directly depends on many concrete classes like this SMS notification, WhatsApp notification, and email notification classes. That means the caller knows too much of the business logic. This is tight coupling and it becomes harder to maintain as the app grows. Now let's run this app. So even though it runs, there is so much of bad practices, right? So right now it is SMS. Let's change the notification type to WhatsApp and run it. There you go. It shows WhatsApp, and same if you say email, it prints the email sent with the message your order is shipped. So now let's quickly look into the good practice using the factory design pattern. So let me close all these classes, all the tabs, and go to a good example. So as we discussed in the PowerPoint slide, it deals with the interface. So here the idea is simple. We're gonna move the object creation into a separate factory class. Then the caller will just ask the factory like, hey, just give me the correct notification object. So the caller will depend only on this one interface, not on many concrete classes. So this is the interface. Now all notification types will follow the same contract, so which is send method. So if you see, this SMS notification class implements the notification interface and overrides the class, overrides a method which is sent with printing SMS sent with the message. Same like WhatsApp. So the WhatsApp notification class implements the notification interface and overrides the method send and prints the WhatsApp message sent with the message. Same as the email communication. So the email notification implements the notification interface, overrides the send method and prints the email sent with the message. So what are the business logic needs will go under this method. Now the key part is the factory. So if you see this class contains the creation logic. So instead of putting if else in many places, we put it in one place. If tomorrow we add any other new mode of communication, we only change this factory and add one new class. We don't touch the main business code. So if you see the notification type is SMS, then it returns the appropriate SMS notification object, and same for WhatsApp and email. Now let's see the caller, which is factory method demo. So see, the caller does not create SMS notification or email notification directly. It simply calls the factory and gets the notification. That means the caller stay clean and stable. So that's the factory method. So to quickly wrap up, the bad version is object creation is mixed inside the main logic and too many if else conditions. But in the good version, object creation is centralized and the main code depends on the interface. Thanks for watching the video, and in the next video we will move to the next design pattern.